All right, if you're a security pro, you know a network failure is an absolute catastrophe. But what if I told you that the most common device on your network, the switch, is also the one people mess up the most? Well, in this explainer, we are going to pull back the curtain on the network switch and show you exactly how to build a network that's not just plugged in, but is truly secure and reliable.
So let me just ask you this straight up. Is your network's foundation actually built to fail? I know it's a heavy question, but look, if you don't really get how a simple network switch works, it can lead to some massive system failures. Let's make sure that is not your story.
Okay, let's get right to it. The best way to think of a network switch is like a really smart traffic cop for your data. It operates at what we call Layer 2, which is just the fancy way of saying it uses the unique hardware address, the MAC address of your devices. Now, this is totally different from an old, ancient hub that would just scream every piece of data out to everybody on the network. No, a switch is smart. It figures out who's plugged in where and creates a private, direct little lane for data to travel. It's way more efficient, way more secure, and it's really the bedrock of all modern networks.
So you get the basic idea. Now you're on a job site, and you've got to make your first big decision. Are you going to go with a dumb, unmanaged switch or a smart, managed one? Believe me, this one choice pretty much dictates everything about your network's capabilities, its security, and honestly, your sanity when you have to manage the thing.
So on one side, you've got the unmanaged switch. Super simple, cheap, you just plug it in and it works. But the problem is, it's a total black box. You have zero idea what's happening inside. Then, on the other side, you've got the managed switch. This thing is your command center. You can log into it, you can see everything, you can control every little detail of how it works. And for a security professional, oh yeah, this is where the magic happens.
Okay, so with all this power that a managed switch gives you, what is the one single killer feature that makes it an absolute must-have for any serious security system? I'm talking about one simple tool that solves one of the most frustrating, annoying problems you will ever face out in the field.
It is the PoE toggle. You know the feeling. A camera freezes at 2 in the morning. Before, that meant getting in your truck. Not anymore. You just log into the switch, you click a button to turn the power off and on for that one port, and boom, the camera reboots. You're back in business. On top of that, you get awesome tools like RSTP, which stops someone from accidentally plugging in a cable wrong and creating a loop that crashes the whole network. And port mirroring lets you diagnose those really tough issues. These things are absolute lifesavers.
And this right here, this is the payoff. This is your return on investment. That one remote reboot, it saves you a truck roll. That's time, it's gas money, and it's a huge headache saved for you and your client. Seriously, the little bit of extra money you spend on a managed switch pays for itself the very first time you use this feature. It's a complete and total no-brainer. All right, ready to really level up your network security game? Let's talk about VLANs. These aren't just some fancy, complicated feature. Think of them as building invisible walls inside your network. And for any secure, high-performance system, they are an absolute necessity. So picture this, right? You've got one big, messy network where your supercritical 4K security cameras are all fighting for bandwidth with somebody in the office who's streaming YouTube. That's what we call a flat network, and it is a recipe for disaster. I'm talking about your video recording skipping frames, or even worse, a giant security hole where anyone can try and access your camera servers. It's just a nightmare waiting to happen.
So what's the solution? It's actually incredibly cool. VLANs. You take one physical switch, just one box, and you digitally slice it up into multiple, totally separate virtual networks. So, just like you see here, we can tell the switch, hey, ports 1 through 12, that's VLAN 10 for office stuff, and ports 13 through 24, that's VLAN 20 just for our security cameras. It's the same piece of hardware, but now they're living in two completely separate secure worlds. And here is the golden rule. You have to get this. Devices on different VLANs are completely, totally isolated. They can't see each other, they can't talk to each other, period. The only way traffic can get from one VLAN to another is if it travels up to a Layer 3 device like a router. And that router acts like a security guard at a checkpoint, inspecting the traffic before it decides if it's even allowed to cross over.
Okay, so we've got smart switches, we've used VLANs to secure our network. Fantastic. Now let's talk about speed. Let's talk about performance. You might look at a switch and see gigabit written on the box and think, great, it can handle a gigabit of traffic on every single port all at once. But that's a really common and potentially very expensive mistake.
Let's do some super quick math. Imagine you've got a 24-port switch and it's full of 24 cameras. And let's say each camera is streaming at about 10 megabits per second. You do the math, and that's a grand total of 240 megabits per second of traffic that you're creating, okay? Just kind of tuck that number away for a second. Now, here's the part that blows people's minds. A typical modern 24-port switch has a massive internal capacity, we call it a backplane, of 48 times gigabits per second. So our little 240 megabits of camera traffic, it is a tiny, tiny drop in a vast ocean. The switch itself is almost never, ever your bottleneck.
So where's the real danger? It's almost always the uplink. That one single cable that connects your switch full of cameras back to your video recorder or the main network. Trying to cram all that data through one little 1 gig pipe is what causes a major traffic jam. So here's your pro tip, your rule of thumb. Never, ever let your uplink usage go above, say, 60 to 70%. If you're pushing more than 600, 700 megabits, it's time. You absolutely have to upgrade that link, probably to a 10 gig fiber connection. All right, one last pro tip for you, and this one really ties everything we've talked about together. When you're in there setting up those VLANs, you're going to see two main options for your ports: access and trunk. And knowing the difference between these two is absolutely critical to getting your network running right.
So an access port is the easy one. Just think of it as a normal port that belongs to one and only one VLAN. This is where you plug in your end devices, right? Your IP camera, your office computer, your door reader. The device itself doesn't have a clue about VLANs. It doesn't need to. The switch does all the work for it, basically stamping all of its traffic with the right VLAN tag.
Now a trunk port. That's your multi-lane superhighway. It is specifically designed to carry traffic from all of your VLANs at the exact same time. You use trunk ports to connect one switch to another switch, or to connect your switch up to your main router. This is the secret sauce that lets your different virtual networks travel between different network closets and all across your entire building.
And so that brings us right back to the beginning. Look, anybody can plug in a cable and get a green link light. That doesn't mean you've built a professional, secure system. It's the smart choices, using managed switches, using VLANs to build those invisible walls, and planning for your traffic capacity that makes all the difference in the world. So yeah, your network is connected, but ask yourself, is it truly secure and reliable? Now you know how to find out and how to make it happen.